Welcome to today's lecture. So from today we are going to start our unit number 2. So first let us quickly discuss the syllabus of unit number 2. So in fluid statics we will be covering three topics. So first is laws of fluid statics. So basically we are going to see what are the different forces on fluid element, Pascal's law, hydrostatic law, and hydraulic ram. Okay. We will also see the problems on hydraulic ram. Okay. After that, pressure measurement. Then we are supposed to see what are the different types of pressure measuring instrument. Okay, mechanical instruments, then piezometer, barometer, manometer, and etc. So this together it will be topic 1, or you can say section 1 of unit number 2. Okay, so it will require almost 6 to 7 lectures. Then hydrostatic forces on curved surface. Okay, so here there will be derivation for total pressure and center of pressure. Okay, then there is another derivation of curved surface, and there are problems on it. Okay, after that, next topic is buoyancy and flotation. We will start with our first topic, that is intensity of pressure. So first of all, let us discuss what is the difference between the pressure and stress. Okay, what is the unit of stress? Newton per meter square. What is the unit of pressure? Same, Newton per meter square. Okay, so basically what is the difference between them? If both are same, consider any solid body. Okay, as shown in the figure. Now consider this is any solid body, and we are applying some force, okay, on this unit area. What will happen in the solid body? Basically there will be number of molecules which are held together in some crystalline structure, okay, like this. So they will be held together by some covalent bonds. Now this force is distributed into small forces df. Okay, and under the action of this df, suppose this is a tensile force. Okay, so under this tensile force, these molecules or these atoms, they will try to move away from each other. Okay, so on this molecule there will be two types of forces. One force, that is applied force, which want to move the molecule away from each other. Okay, and second will be some attraction will be there, which will try to resist, okay, this force. Okay, ये जो आपके मॉलिक्यूल्स का मोशन होने वाला है, डिफॉर्मेशन होने वाला है, इसको कोवलेंट बॉन्ड या फिर आप इंटरमॉलिक्यूलर फोर्सेस बोलेंगे, वो ऑपोज करती है. ओके, सो सम रेजिस्टिंग फोर्स इज व्हाट विल कॉल इट इज वो उसके अंदर एब्सॉर्ब हो जाती है. ओके, और जनरेट हो जाती है. सो सम रिस्टोरिंग फोर्स दैट इज जनरेटेड. ओके, एंड व्हेन यू रिमूव दिस फोर्स एफ, आप जब ये फोर्स एफ रिमूव करोगे तो ये बॉडी का जो भी इलोंगेशन हुआ है, इट विल रिगेन इट्स ओरिजिनल शेप एंड साइज. ओके, सो दिस इज one of the property which is shown by any so this is the property which is shown by any fluid, any solid. Okay, so solid have a definite crystalline structure, and under the action of that, the solid have property to regain its original shape and size. Okay, so whatever the internal resisting force generated per unit area, okay, whatever the internal resisting force generated per unit area, that is called as stress. Okay, and basically stress are generated in solids. Okay, now we will understand what is pressure or intensity of pressure. Okay, now the unit of pressure, it will be Newton per meter square. Okay, similarly in a CGS system, its unit is dyne per centimeter square. Okay, after that, the another unit of pressure, it is kilopascal. Okay, so remember 1 kilopascal is or 1 Pascal equals to 1 Newton per meter square. So 1 kilopascal is 10 power 3 Pascal. So it is 10 power 3 Newton per meter square, or 1000 Newton per meter square. Another unit is bar. Okay, so remember 1 bar equals to 100 kilopascal, or 100 into 10 power 3, so 10 power 5 Newton per meter square. Okay, after that, dimension. Now remember dimension of pressure is nothing but dimension of force upon dimension of area. Okay, dimension of force already हमने यूनिट 1 में देखा है, force is nothing but mass into acceleration. So m1 l1 t minus 2 divided by area. So area is m0 l2 t0. Okay, so l2 numerator में जाएगा, so it will become +1 -2, so -1. Okay, so the dimension of pressure is m1 l minus 1 t minus 2. Okay, so remember the dimension of pressure. So dimension of pressure is m1 l minus 1 t minus 2. Okay. After that, next is Pascal's law. So this Pascal's law states intensity, the pressure or intensity of pressure at a point in a static mass of fluid, okay, is equal in all directions. Okay. So this law states the proof of Pascal's law. Okay, so consider any wedge shape element. Okay, now consider this is any wedge shape element of dimension dx dy along x and y direction, and the slant edge distance is ds in along s direction. Okay, so consider a wedge shape element of dimension dx dy and ds along x y and slant direction respectively. Okay, then consider whatever the width along the in perpendicular direction to the plane of laptop. Okay, लैपटॉप को जो परपेंडिकुलर डायरेक्शन है और ये स्क्रीन को जो परपेंडिकुलर डायरेक्शन है, उस डायरेक्शन में उसका विड्थ जो है हम अज्यूम करेंगे दैट इज यूनिटी. ओके, then let px, py and ps, these are the intensity of pressure perpendicular to or in the direction of x, y and z s respectively. Okay, so px, py, ps, these are the intensity of pressure perpendicular to face AB, perpendicular to face AC and perpendicular to face BC as shown in the figure. Okay, therefore if these are the pressure, then pressure forces, okay, or the total forces acting on the element are, first will be the pressure forces. Okay, pressure act हो रहा है तो उसको आप एरिया से मल्टीप्लाई कर दो, so pressure forces, and second will be weight of the fluid element, okay, in downward direction. So we will resolve these forces along x and y direction. So first of all, the forces on faces are force on face AB. Okay, force AB पे कौन सा force है? Px. Px into area of AB. So area of AB is length is dy. Okay, so dy into perpendicular width कितना है उसका 1. So dy into 1. Okay, so it is Px into dy into 1. Similarly, AC पे कौन सा फोर्स रहेगा? Py, और Py कौन से फेस पे एक्ट हो रहा है? AC. सो AC का विड्थ है dx. ओके, सो Py into dx और विड्थ कितना है उसका 1. सिमिलरली फोर्स ऑन फेस BC. सो फोर्स ऑन फेस BC it will be simply PS or PZ. Okay, PZ लिया है. Okay, it is not PZ. Okay, PZ into उसका विड्थ कितना है, हाइट कितना है ds into विड्थ कितना है 1. Okay, so these are the forces which are acting on AB, AC and BC. Now we will resolve these forces along x and y direction. After that, weight is nothing but mass of the element into g. Okay, now we know mass is nothing but rho into volume. Okay, so it is mass density into volume into g. Now volume of this wedge shape element, okay, इसका फेस क्या है? ट्रायंगुलर फेस है. So it is 1/2 width is dx into height is dy into उसका जो z डायरेक्शन में width कितना है? 1 है. ओके, so AB into AC into 1 divided by 2 into rho g. Okay, so it is simply dx into dy into 1 upon 2 into rho g. Now we will resolve these forces in x and y direction respectively. Okay, so first of all we will resolve these forces in x direction. Okay, so x direction में कौन सा force act हो रहा है? First of all this force is acting, so this px into dy into 1. Okay, after that ये py into dx into 1 ये y direction में, so हम इसको नहीं लेंगे. After that suppose this angle is theta. Okay, so this angle is theta and this angle is also theta. Okay, so this angle is also theta by geometry. तो आप ये जो फोर्स है pz into ds into 1 इसको रिजॉल्व करोगे, so that resolve component will be cos theta. Okay, so that is sin of 90 minus theta, or sin of 90 minus theta is simply cos theta. Okay, so it is px into dy into 1 minus pz into ds into 1 into cos theta. Okay, so you can call this some equation. Okay, after that we will do one thing. यहाँ पे हम we will take this triangle ABC. 1 minute. ट्रायंगल ABC, ये ट्रायंगल में क्या हो रहा है, cos थीटा. तो cos थीटा we will say cos theta is nothing but opposite. Opposite is AC upon adjacent. Adjacent is AB. Sorry, cos theta is adjacent upon, sorry, cos theta is adjacent. Adjacent is AB upon hypotenuse, that is BC. So AB upon BC. Okay, so this is dy. Okay, AB is dy. So dy upon hypotenuse is ds. Okay, so you can multiply this ds to cos theta, so you will have dy equals to ds cos theta. Okay, so ds cos theta equals to AB, that equals to dy. Okay, so you can put this value in above equation. So we will have px into dy into 1, that equals to pz into ये जो ds cos theta था, so that is dy, so dy into 1. Okay, उसके बाद में and it will be downward, so negative. After that, next will be weight of the fluid element. So we will have py into dx into 1 and acting upward, so positive, minus ps into ds sin theta. Okay, just हमने अभी डिस्कस किया था, and it is acting downward, so negative. Then weight is also acting downward, so it is rho g into ab और ac का वैल्यू पुट कर दो, so dx dy, so dx dy by 2 into rho g. Okay, now remember in this equation, suppose dx का वैल्यू है 0.1. okay, dy का भी वैल्यू है 0.1. ओके, सो जब आप इन दोनों को मल्टीप्लाई करते हो 0.1 into 0.1, so it is 0.001. okay, so the product as dx is small and dy is small, so the product dx into dy, it will be very very small. okay, therefore we can neglect that term. okay, so हम इसको neglect करेंगे, so we will neglect this entire term. okay, and remember here again in this triangle ABC sin theta. okay, so that equals to opposite. Sin theta is equal to opposite is what, uh sorry, AC upon BC. okay, 1 minute. okay, sin theta is equal to AC upon BC. AC upon BC. okay, so we know AC is what, AC is dx upon ds. okay, so dx is nothing but ds sin theta. okay, so you can put that value. So ds sin theta is nothing but dx. So putting in above equation and neglecting this third term, so we will have py into dx into 1 minus pz into dx into 1. okay, अब ये जो टर्म है माइनस साइन, ये वाला राइट में ले जाओ, एंड देन dx into 1 cancels from both sides. So finally we will have py equals to pz. okay, so here px equals to pz and here py equals to pz. So equating these two terms, okay, so we will have px equals to py equals to pz. okay, that means whatever the pressure or intensity of pressure acting on the fluid element, okay, so that is same along x direction, along y direction, and along any slant direction. okay, okay, remember this Pascal's law. It is very important law because most of the hydraulic machines, okay, आपकी जितने भी हाइड्रोलिक प्रेसेस है, आपकी जितने भी हाइड्रोलिक मशीन्स है, ओके, जेसीबीज है, ओके, आपके जो न्यूमेटिक मशीन्स है, all are working on Pascal's law. okay, so Pascal's law forms one of the basic law of hydraulics. okay, so ये बहुत important law है. okay, now what आपके जो हाइड्रोलिक रैम्प्स होते हैं, ये भी आपके पास्कल्स लॉ पे एक्ट हो रहे हैं. नाउ क्या होता है पास्कल्स लॉ के हिसाब से? ओके, वी विल सी. Now consider this case. In this case, there is a small area. Okay, so this small area is A1. Okay, and on this small area A1, suppose आप आपके फुट पेडल से स्मॉल F फोर्स लगाओगे F1. ओके, सो आप कितना प्रेशर जनरेट कर रहे हो? प्रेशर इज F1 एंड एरिया इज ऑल्सो A1. ओके, तो यहाँ पे सपोज आपने 1 न्यूटन का फोर्स लगाया और यहाँ पे एरिया जो था वो 1 मीटर स्क्वायर था. ओके, सो आपका प्रेशर कितना हुआ है? 1 न्यूटन अपॉन 1 मीटर स्क्वायर. सो बेसिकली 1 न्यूटन पर मीटर स्क्वायर, इतना आपने प्रेशर जनरेट किया है. ओके, नाउ एज पर आवर पास्कल्स लॉ, ये जो प्रेशर है, ये प्रेशर जो है ये पूरे फ्लूइड में कांस्टेंट रहेगा. ओके, और अदर एंड पे भी सेम प्रेशर एक्ट होगा. सपोज यहाँ पे एरिया A2 जो है, ये एरिया A2 100 मीटर स्क्वायर है. ओके, तो बेसिकली हमारे पास्कल्स लॉ के हिसाब से ओके, प्रेशर एट 1 equals to pressure at 2. Okay, therefore 1 upon 1, okay, pressure at 1, so that equals to whatever the force which is generated at 2 divided by area of 2. area of 2 is 100 मीटर स्क्वायर. तो ये 100 मीटर स्क्वायर को आप इधर मल्टीप्लाई करो तो बेसिकली फोर्स कितना जनरेट हो रहा है? 100 न्यूटन. ओके, दैट मीन्स आप अप्लाई कितना कर रहे हो? 1 न्यूटन, और अदर एंड पे जनरेट कितना हो रहा है? 100 न्यूटन. ओके, सो ऑल दिस इज पॉसिबल बिकॉज ऑफ दिस सिंपल लॉ विच इज कॉल्ड एज पास्कल्स लॉ. ओके, तो दिस इज द रीजन व्हाई आपने देखा होगा कि इंडस्ट्री में एक छोटा सा पेडल होता है, या फिर एक छोटा सा हैंड पेडल होता है, नहीं तो फुट पेडल होता है. ओके, और हैंडल होता है. ओके, और आपने देखा होगा कि वो हैंडल वर्कर प्रेस करता है, और बड़ा से बड़ा प्रेस मशीन जो है वो मेटल की शीट को ब्लैंक या पंच कर देता है. ओके, सो एक स्मॉल फोर्स के कारण ही इज एबल टू जनरेट दिस मच फोर्स. और गैरेज में आपने देखा होगा कि जो गैरेज का जो वर्कर होता है वो फुट पेडल से कार को लिफ्ट कर लेता है. ओके, या फिर आपने देखा होगा जेसीबी मशीन. तो जेसीबी मशीन में बेसिकली एक छोटा सा हाइड्रोलिक सिस्टम होता है जिसमें हम इलेक्ट्रिसिटी अप्लाई करते हैं, और बेसिकली पंप क्या करता है? प्रेशराइज करता है फ्लूइड को, और वो प्रेशराइज फ्लूइड के कारण जो हाइड्रोलिक सर्किट है उसमें फ्लो होता है, एंड जेसीबी इज एबल टू लिफ्ट, और क्रेन इज एबल टू लिफ्ट thousands of kilograms of weight. Okay, so all this is possible because of Pascal's law. Okay, so remember, Pascal's law forms one of the most basic law, and it is the foundation of hydraulics. After that, numericals on hydraulic ram. So a hydraulic press has a ram of 30 centimeter diameter and a plunger of 4.5 centimeter diameter. Find the weight lifted by the hydraulic press when the force applied at the plunger is 500 Newton. So this is your given problem. So this is a plunger पे आप 500 न्यूटन फोर्स अप्लाई कर रहे हो और इसका डायमीटर 4.5 सेंटीमीटर है. ओके, एंड आपका जो रैम है उसका डायमीटर है 30 सेंटीमीटर. So capital D is 30 centimeter 0.3, small d is 4.5 centimeter, that is 0.045 meter. Then you can calculate the area, capital A and small a. So capital A is pi by 4 capital D square, small a is pi by 4 small d square. So pi by 4 into 0.3 square, pi by 4 into 0.05 square. So capital A is 0.07068 meter square, and small a is 0.00159 meter square. Okay. The pressure on the plunger, or pressure intensity due to plunger, that is force on plunger upon area. So F upon A, so 500 divided by 0.00159 square. Okay. After that, so it comes out to be 314465.4 Newton per meter square. अब यहाँ पे जो फोर्स प्रेशर जनरेट हुआ है, as per Pascal's law, this pressure will remain equal in all direction. So ये जो प्रेशर है ये ट्रांसमिट होगा. ओके, और बेसिकली रैम में ये रिलीज होगा. ये जो प्रेशर है ये यहाँ जाके रिलीज होगा. ओके, सो ऑन द रैम द एरिया इज 0.0768 स्क्वायर. Okay, so that same pressure, okay, so intensity of pressure at ram that equals to weight upon area of ram. तो weight हमें पता नहीं कितना लिफ्ट करता है, so W upon A, so W upon 0.07068 square Newton per meter square. Okay, then as per uh, Pascal's law, intensity of pressure at plunger, it should be equals to intensity of pressure at ram. So W upon 0.07068 that equals to 314465.4. So you can multiply them. So finally, the weight comes out to be 22222 Newton. That means 22.222 kilonewton. Okay, so 22 kilonewton of weight can be lifted. Okay, by applying 500 Newton on plunger.